Hello, it's Darius, and in this video we're going to be talking about the document object model. Now, I'll get to the challenge in a few minutes, but I wanted to go into some detail and overview of this whole DOM thing first. So, whenever your page is loading, the parser will always see the body first. There's the head, okay, but as it's going through the body, it's going to see whatever elements are inside there, and it goes line by line. And as it parses out each tag, it assembles this tree representation of the HTML text document. And so you would end up with something tree looking, but simultaneously the parser is also creating a JavaScript object for every element as it parses. So there is a HTML body element, one of them that's created for the body, and then for every div there's an HTML div element. And the parser also creates the same parent-child relationships in the JavaScript tree that exists in the HTML tree. And this is very handy because that means that if I want to reference this input element in the JavaScript where I'm programming, I can use this one down here, an instance of the HTML input element that exists in JavaScript, and it has its own properties like value, and you could even tell JavaScript to run some function whenever a key is typed, so you can interact with the elements on the page using the document object model. Okay, so every single element has a one-to-one relationship with a JavaScript element, or a JavaScript object rather. Okay, now let's get into the challenge. Well, in case you're wondering, this is a example of what that tree might be. Let me bring it up. So there's a tree representation, and then this is a textual representation of that same tree. Alright, fair enough. On to the challenge. So we're supposed to create this word count program, and there's two ways to do this that I came up with, but let's start with the first, and that is we're going to just initialize a counter, and then we're going to use for each to iterate through each what I call element in the haystack. So I use the common analogy of finding a needle in a haystack. So in this case, the needle would be the word you're looking for, and the haystack is a list, or an array rather, of all the words. I use for each to iterate, and then an if statement to check if that item is in fact the needle, and if it is, you increment the count, and finally you return the count. And this all works fine and dandy. So the quick brown fox jumped over the lazy dog, which is just the most overused sentence for like testing fonts and stuff like that. But it works. The word the appears twice in that sentence. There is a second way that is more confusing at first, but certainly less writing code, less keystrokes, and I want to talk about that. I'm gonna expand this a little bit. You know what? I'll rewrite it. There's too much going on here. So we're recreating that same behavior, but you can see I'm already jumping to return on my first line, so I must be pretty aggressive here. I must be pretty confident. But I'm going to be using the reduce method of an array. So, wow, if you take a look at the arguments that reduce accepts, it's a little overwhelming. So let's, the first thing that you're going to give it is a function, the callback, just like in the for each, except this time the first parameter is not the item, it's a sum or an accumulation variable. I'll explain that in a second. The second guy is your item. And you can have your body of your function. But before we jump to the next line, I'm going to put a comma just to remind us that something else goes there. That is another argument. Alright, so what's with this whole sum thing? Well, every time that you return some value from this function, it will set that value equal to, or sorry, it will set sum equal to that value. What does that mean? If I return sum plus 4, then every time this function runs, it will add 4 to sum, and then it'll set that equal to sum, and then it'll add 4 to sum, set that equal to sum, and it will increment by 4 each time, okay? I mean, there's better ways to do that in JavaScript, but bear with me. The other thing we can do is set an initial value, which is going to be like 0 in our case. This is going to be our count. So you know what, let's do that. Well, instead of sum, we'll call it count, because that's pretty much what it was in the other one. And we're not just going to add 4 for every item. That would be ridiculous. We are going to add 1 to the count if the needle is equal to the item. And we're going to add 0 or nothing at all if it's not. We could do this with an if statement, but I want to show you something a little funky you can do with a Boolean. So remember that a Boolean is a true or false value, but converted to an integer, a true is a 1 and a 0, false is a 0. What that means is, if I put the comparison inside some parentheses, just so that we're not comparing the wrong thing, then the result of the comparison will be treated as an integer, and we should see that it will this should work. Nice, we still get 2. So that's the reduce function. You give it a callback with 2 parameters, a count or a summation or an accumulator, an item, and then whatever you return is what you want count to be the next time. And so you can use count. And of course, item is just like it is in for each. That's wonderful. There's one more thing I want to show you, and that is, this is pretty messy and long. Not fun to type that all up. Instead, we will use a method of a built-in method of strings. and that would be split. And the split method just takes another string, and you can give it a character. You want it to split the string at that character every time it occurs, and it will return an array of all of the segments. So if I just split it at every space, then I'll end up with an array of the words. And for me to test this with a sentence, it just makes a lot more sense to do that. Same result. But I just want to show you that to learn and to keep that in mind as you grow your knowledge of JavaScript. Okay, that's enough with all this word counting stuff. Oh, I called it a word count, but technically it's just a count. It doesn't have to be a word. Interesting enough. You know, there's nothing about any of these functions or operations that is inherent to strings. And isn't that funny that it's also two? Let me just put another one in there so that I prove I'm not lying or something, and it's always printing two. There we go. Anyway, it's just a count function. It's wonderful. Okay, on to the meat of this tutorial. We're talking about the document object model. I want to show you a practical example of that. So yeah, let's make an input. This is some HTML. I'm going to give the input a name. We'll call it message. And we should probably give it a type. We're gonna go type equals text. Sorry, that has an E in it. That's HTML. Back into JavaScript. And we can use the document object. We use a method called getElementsByName. That's one way to do it. And in this case, we provide a string that is a name of, or a name attribute for HTML element. So it's gonna go through our entire HTML tree and find every tag that has a name attribute equal to message. And there's only one. We know that there's only one, so I'm going to go ahead and reference the first item. I'm using constant because I have no intention to reassign the value of input. And there's our input. We can type in it, but we also see in the console it printed this kind of pretty representation of what's actually a JavaScript object. Woo! Look at all that stuff it's got. Okay, so this is not just an HTML tag, even though it looks like that's what it is. It's tied to the HTML tag. It kind of corresponds, represents it, but it's truly a JavaScript object. Just like any other object, it has properties and values and such. You can see some of the attributes showing up in this list. Inspect it. It has no children. Alright. But the important thing is we now have a reference in our JavaScript to this guy. And what I want to do is introduce another topic, and that's event listeners. So whenever the user interacts with a page, it will fire events in the JavaScript that notify the program about just the actions that are happening. Okay, so whenever I am typing keystrokes in this box, JavaScript will be firing events, and anything that wants to listen to those events, those messages, will be notified and can I'll show you. So we've got our input. It's pretty easy to add an event listener. We just provide a function. The first argument is an event object with some more details about it, such as what node or what element the event was fired on. And so that's referenced through event.target. That is the thing the event was fired on. So like if it's a key, the first parameter is very important. It's not just a function. The first parameter is a string telling you, or telling JavaScript, what event you want to listen to. In this case, it's input. That's a little bit confusing considering that input is also the name of an HTML tag, but input is just going to fire every time a key is pressed and released, I believe. Because you could listen to key down, you could listen to key up. There's so many events you can listen to in JavaScript, and you really would just have to go on to, MDN docs or W3 schools and reference it many times until you are familiar with the most common ones, and they're even adding new events. But you could listen to input, which will fire on every keystroke. And let's just console.log input.value. So there you go. I'm pressing keys. And it looks like it is actually, I think it's the same as a key down event. And then the value is not the thing that you last typed, the single character that you typed. The value is everything that's in the text box. Okay. Now, that's just some of the most, that's the value, okay? The value property, and that's pretty common for all sorts of input elements, but just about every HTML element has its own kind of unique DOM with its own properties, methods. If it's a video element, it has play and pause functions. Same with audio. So you have to treat them all a little bit differently and get to know them. I won't go into all of them. I will put a button on here because buttons are just super common. I'll show you another way to reference elements. You can get by ID. IDs are unique, so you don't have to index because it doesn't return an array, it just returns an object. Okay, and a button has a click listener. I'll log the value. Oh wow, isn't that funny? I forgot to give the button some text. It's super tiny. Well, there's QWERTY. And whenever I click the button, it console.logs the value. Nice. So as you can imagine, there's so much more that goes into the DOM because it's a continual learning process as new elements are invented and introduced into the web stack specifications. And there's already a lot out there. And so you get familiar with these as you make applications. I do want to introduce the challenge for this video. And this challenge is going to be a password strength indicator. So you go to log into a site or you're creating an account. Sorry, I can't type and speak at the same time. You're creating an account and you start typing your password and it starts out like in red or something, and then whenever you get a certain length it goes yellow and then it goes green when it's long enough. We did something kind of similar in a previous challenge, but this time we're using actual user interface elements. You should have a text input, of course, and then some kind of text, maybe like a paragraph tag, or maybe even go fancy and use some CSS to change the color. However you want to do that, you should probably listen to the input event on keystroke and then dynamically change the display to notify the user whether it's weak, medium, or strong password. Alright, that is the challenge. Have fun with it, and I'll see you in the next video. It is a little bit of a tricky challenge if you're new to DOM, so feel free to struggle with it a little bit and then watch the next video.